Objective 2, Day 2 homework. And unfortunately, since I managed to mess up the back side of this homework for you guys, it's only 4 problems, so I'll give you the other problems on a different homework at some point. So we have the foundations of functions is those 3 problems. And then we have the patterns, which is problem number 4, and the back side was supposed to have a bunch more. I just didn't get them to you. So I'm going to go over all 3 of these with you now. Or all 4 of them, sorry. So we're doing, the answers is number 1 is D, number 2 is C, 3 is B, and 4 is also B. And so problem 1, it says, which of the following best represents the range of the function shown to the right? And the first thing you want to remember is that range is not just the y values, but all the possible y values. Okay. They're looking for you guys to make several mistakes. One of them is that you were looking for the domain, in which case the domain would be forever in that direction and forever in that direction. That would be A, but that's not asking about domain, it's asking about range. So we need to look at these other 3 numbers and see what it is. And basically, the smallest possible y value that you have on this is -4. It doesn't go ever below -4. And the largest possible y value you have is infinity, because these arrows tell us that it goes on forever and ever. So your only possible answer is D, is that it's all of the real numbers, or any number that's bigger than -4 and also includes -4, because it does touch -4. Okay. Number 2 says, which of the following represents the parent function of y equals x squared minus 2x minus 15? And this one, in my opinion, is a little bit tricky, because like I told you guys, you get rid of the numbers and you have your parent function, in which case you would have y equals x squared minus x. You could argue that that's the parent function. However, they're simplifying it a whole lot more, and they're saying x squared is the biggest x in this, so we're going to just ignore that guy and say that it's c. And it actually makes sense, because this would be a parabola. It's just that that extra x term right here moves it a little bit, but it's still a parabola, so the parent function is still x squared. And one more thing just on that last problem. If you just remember what I was saying in class, they can only test you on 2 parent functions. So the moment that you see this word in a question, or this phrase, parent function, you go straight away to the answer choices and you cross off whatever is not equal to x or equal to x squared. So this guy is not even a parent function, and this guy is not even a parent function. So you want to do that before you even try to answer the question. That way you know for sure you have at least one out of 2 to pick from. Okay, number 3, which of these are the characteristics of the parent function of a quadratic equation? And so the parent function of a quadratic equation, it looks like this. And right away when you get this problem, you would go into the calculator and you would graph y equals x squared, which is the parent function of a parabola, or a quadratic function. So we look at now at these choices, and it says the parent function of a quadratic equation has the vertex at 0, 0. Remember that vertex is wherever this bottom point is, the turning point. If the parabola were facing the other way, it would be that point right there. So for the parent function of a quadratic, it is right there. I'm sorry that my drawing is not that good, but if you graphed it, you would see that it's right at 0, 0. So that one is true. The parent function of a quadratic equation opens up or downward, and clearly this guy is opening upward. The cup is on the top, so it's facing up, and this is wrong. And then the last one, the parent function of a quadratic equation has the y-axis as its line of symmetry. So here's your y-axis. Line of symmetry is where you could fold the parabola over and have it look exactly the same. So if you folded it over here, this leg right here would lay right on top of this leg right here. And so this is your axis of symmetry. So that works, or your line of symmetry. So that means that your answer is 1 and 3 only. Okay, and then the last problem deals with substitution, so we're kind of shifting gears here. It says the square tiles below are arranged to show a pattern. Which expression can be used to determine the number of squares in stage n, or the number of tiles? Remember that you want to look here to see what n stands for. And we actually did this problem in class, but just in case you don't remember, I'm going through it again. So stage n tells us that n stands for the stage number. So in this one, n equals 1. Here, n would equal 2. Here, n equals 3. And here, n equals 4. So you've got to find this little key here that tells you what that letter stands for. So we're going to plug these into our answer choices and see which one works. I'm going to try A first, and I'm going to start with the first one. So I'd say 4 times 1 plus 3, and that equals 7. 4 times 1 is 4, and then add 3 is 7. And if you count these, you have 1, 2, 3, 4, 5, 6, 7. So there's 7 squares, which means that that works. We got 7 here, and there's actually 7 that we're counting. So far A kind of looks good. Let's try stage 2 now. We have 4 times 2 plus 3 once again. So that's 8 over here, and then plus 3 is 11. And if we count these squares, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that doesn't work because we wanted 12 and we got 11. So A is out. Let's try B now and see if that works better. So we have 5 times 1 plus 2. 5 times 1 is 5 plus 2 is 7, and that's what we got here, so that works. Let's try the next stage. 5 times 2 plus 2. 5 times 2 is 10, add 2 and you get 12, so that works because we actually have 12 there. So now let's try stage 3. 5 times 3 plus 2. 5 times 3 is 15, add 2, you get 17, so let's see if that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that looks good. Let's do the last one just to be super sure. 5 times 4 plus 2. 5 times 4 is 20. Add 2 and you get 22. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would also be 9. That's 18 total. 19, 20, 21, 22. So that works. So now we see that our answer is indeed B. Of course, on the real tax test, you would go through and just to be on the safe side, you're going to do C and D, just to be sure that you didn't make some sort of mistake that makes B work, even though it's not actually the right answer. You always try every single answer choice. Okay, so that's the end of this really short typo homework, and then I'll show you the rest of it tomorrow when we give you the rest of this homework. All right, bye.